Hi, my name is Ray, and my student ID is 190857779D. Today I'm gonna show you how to investigate pressure law, part 1. In part 1, we'll talk about Gay-Lussac's law, and it shows the pressure and temperature of an ideal gas are directly proportional as long as its volume remains a constant. For safety concerns, it is better for you to prepare gloves and goggles to conduct the experiment. In today's experiment, we need to use the following equipment: a candle, water, lighter, a beaker, and a container. First of all, pour the water into the container. Then light up the candle and put it in the container. Remind that the candle is higher than the water level. Afterwards, apply the beaker onto the candle to seal the gas in the beaker to form a sealed place. Make sure the volume is fixed. And that's the whole process of the experiment. At the end of the experiment, we'll see that the water level goes up higher and then stops at a certain level. Here's the reason. As the temperature initially keeps raising, the pressure inside the beaker raises either. A few moments later, the candle stopped burning, and the temperature inside started to cool down. So does the pressure in the beaker starts turning low. However, the air pressure outside the beaker is now larger than the pressure inside. In order to balance the pressure inside the beaker, the water level starts rising to balance the pressure in and out the beaker. This phenomena is how the Gay-Lussac's law stands for. Okay, let's talk about part 2. In part 2, we're gonna show you that the pressure is proportional to the velocity, also known as Boyle's law. In this experiment, we need to use the following instruments: Boyle's law apparatus with pump. This experiment is actually pretty safe, so just make sure that you conduct this in a spare place and the whole process is conducted pretty well. Okay, let's get started. Basically, while the temperature of the instrument remains the same, we are here to alter the pressure to the device. Then we may visually check the change of the volume. As we can see, while we keep putting pressure by the pump, the fluid inside the instrument keeps rising up, and the space of the ideal gas keeps shrinking, which means its volume keeps getting smaller and smaller. According to the result of part 1 and part 2, in the first experiment, we can see that pressure P is proportional to temperature T. Also, in the second experiment, we can find out that pressure P is proportional to 1 over volume V, which means P times V remains a constant. According to the above observed results, we may conclude that PV equals to NKT, whereas K is a constant and N stands for the mole of the ideal gas. With further precise calculation, we may find out that the ideal gas formula, P times V equals to nRT, whereas R stands for the ideal gas constant and equals to 8.3144 joule over K mole. So this is how we investigate pressure law. Thank you.